Alright guys, so look here. First guy, so what are you looking for when it's in this form? Like which one of these is not a function? Yeah, this guy's not, because I can see two arrows coming off of one dude, right? So that 5 would go to 3 and 2. And this one is fine. Even if two of them share an output, it don't matter. Does 5 have one output? Yeah. 6 has one output? Yeah. 8 has one output? Yeah. So this, yeah, that's a function. Why or why not? No x's go to more than one y. Now why is this not a function? You would just say 5 goes to 2 outputs. So this is a no. It's like I'm saying no here. Yeah, okay, yeah, no. So do you see the connection between these two things? Like here, what would the points be that this goes through? This goes through the points 5, 3, 5, 2, right? So that's why when you have it given to you like this, what you're looking for is repeated x's. 9 goes to 1, but it also goes to -5. So what's true about this guy? Is he a function?
No.
Not a function. What about this guy? Yes, everything goes to one output. Each input has one output, and this one you would say 9 has more than one output. That would be the explanation. I like it. Now this guy is obviously, is he a function or no?
No.
Yeah, if you draw a vertical line, you can find several. All you need is one. Just one vertical line goes through more than once, not a function. What about this guy? Yeah, he's a function. Every vertical line I can imagine goes through only once. So you can say passes vertical line test. The volt. I like it. And then we got these guys, which here's the correct way. That's right. And by the way, let me do this on the back real quick. So how do you read this? You read this as f of x. This is f of 3. Somebody read this for me. How do you read this? Square root of 16. So I can't divide this by the square root symbol or something. I can't divide this by 16. No, square root of 16 is a number. So f of -1 equals a number, and I stop, because then I figured out what f is at -1. I can't divide by -1. It's inside the f function. You can't divide by it. So f of -1, which function am I using? Obviously the f dude, right? So I just put a -1 in. And what's -2 minus 1? -3. Sure. So what's one point that this function goes through? -1, comma, -3. There's another advantage to this notation. You can see the whole point. So h of 3, you would just put a 3 right there. 3 squared minus 1, which is 9 minus 1? 8. How are we doing? Are you guys all right?
Yeah.
So it's just substitution. People make such a huge deal out of function notation. Nah, it's different letters, so I know which one to use. And then you just plug this shit in there. You plug it in. So how do you g of 1? I would put a 1 in here. And I notice something right off the bat. What is 0 divided by 6? Thank you. What about h of m? Yeah, put an m in place of x, so you get m squared minus 1. That's it. See, that's even nicer when it's a letter, because then you can't do anything with it. So you just stop. So you're really just replacing x with m. which I know right now seems like, why? But there is a purpose for all this. So this is the one that tripped a lot of you guys up, and I don't blame you, because we haven't really looked exactly at this, but I want you to put a few things together. Domain means all the x values I'm allowed to use. Does that function have a problem somewhere? Fundamentally, what is that function? Any number I put in for x, I'm going to end up with what kind of a number? Fraction. And what can't happen in a fraction? Bottom can't be 0. So then you really kind of recast this question. Domain means all the values of x I'm allowed to use. That's got a problem where maybe there's a value of x that makes it undefined. All right, so let me say it's everything else except what makes it undefined. What makes that g of x undefined? What makes the bottom 0? -5. So the answer to this would be everything except -5. All real numbers except -5.
So what if you had a line that wasn't a fraction like that? What would make it undefined, essentially?
So the
2x
reason,
minus 1.
like if I said, what's the domain of f?
Root.
Let's see, let's add another question. Domain of
Yeah.
f. Does f have an issue? See how this had an issue? Because it has a bottom.
Yes.
Does this have an issue? No. Is there any number I can't double and then subtract 1 from it? No. There's no bottom to it. There's no square root. We'll see later that square roots can only handle certain numbers. So their domain is going to be not all numbers. This one, though, the domain of f is going to be all real numbers. Because I can double any number I want to. Take 1 away from that thing. This guy, the form of it has a bottom, so there might be a value that makes it undefined. Oh, shit. So this guy would be all real numbers. This guy would be all real numbers except -5. Why? And I love this question. This question, when you first see it, you're like, how the shit? This is number 3. This does not refer back to this. It's a whole different problem. So I didn't tell you what f was. But I've already given you all the work here. So what must f of -1 have been? Well, they put the point there. So the output must have been -3. Done. So when I give you a graph, that is a visual representation of all the answers. So I'd rather get a graph than a function. I can just look and get the answer and be done with it instead of having to do all this work. Okay. Remind me what domain is.
All the x values.
All the x values that I can use. So another way to say it is all the x values that actually work, that actually have an output. So what's the smallest x that has an output? It's the smallest value for x that has an output on this picture. 0 has an output, I agree with you, but isn't there smaller values of x that have an output? -3 is if you try to go past it, it freaks out. It doesn't go anywhere. So the domain is -3 all the way up to, where's the last place I see my graph? 2. Be careful, I'm walking along the x-axis because domain is x values. So I sometimes I'll teach this, I'll say there's a little dude walking on the x-axis. Where's the first place he sees the function? At -3. And he sees it, he sees it, he sees it, he sees it. After 2 it's gone. So range, you do the exact same thing except you put your little dude on the y-axis. What's the first time he sees the function? No. -3, see, he sees it right there. He's on the y-axis. At -3, he sees it. And he sees it, he sees it, he sees it, he sees it all the way up to 6. So domain is x values. So you just answer all the x's that actually have an output. Range is just what all the outputs are. I know, we're doing a lot today, I know. All right, now this is a step back. So this is kind of like what's going to be on this quiz on Monday. How do you find the slope for this dude? This is nice.
Count the rise.
Count the rise, I like it. So 1, 2, 3.
Count the rise.
And I run how much? 2. So it's up 3, over 2, so 3 amps. Nothing was negative because it didn't fall. Now if I would have went down 3, I would have also went back 2, which still becomes positive 3 amps. Yes.
I just had a cool question. So for on the test, would you like us to write it out how y equals mx plus b with the slope, or would you just like us to write that answer?
All I needed was a slope, so the answer to this is going to be a number.
Okay.
If I said find the equation of this line, then you would have had to do more. In fact, it's not graded, I don't give a shit, don't give him shit either. What is the equation for that line? I have the slope, what's the only thing I need that I can see?
The y-intercept.
Y-intercept, yeah. So what's the value of b? Gotta be -2. So what's the equation of the slope of the line? 3/2 x minus 2. mx plus b. So the equation of this line, I know I didn't ask for it, or just put a part b on this. The equation would be 3/2 x, because that's the slope, minus the y piece of the y-intercept. Or I mean, plus the y piece, the negative. So I could ask you what's the equation and give you a graph. What do you always need? The slope and a point. If it happens to be the y-intercept, you know that kicks ass. I can just put it in for b and be done with it. Alright, now what about, this is kind of like the reverse of this. Given this, how do I find the slope and the y-intercept? Solve for y. Like, oh, I'm sorry, you said get y by itself. Okay. I thought you said something else. So what's the first thing I would do? Add 4x, so I get 5y equals 4x minus 15. And then I divide by 5. When you divide, you've got to divide everything. Nobody can escape. So we get y equals 4/5 x minus 3. So what's the y-intercept? 0, -3. What's the slope? 4/5. So where do I start?
Your y-intercept.
Yeah, 0, -3. Jesus, Jeff. 0, -3. Bam. And then I go up 4. 1, 2, 3, 4. Over 5. How could I check what I did? Maybe it is better to have it like that. How can I check that? What point did we just get? What is that point? What must it do, considering it's on this line?
Plug into that.
It must work in this. So if I plug a 1 in for y and a 5 in for x, what is 5 minus 20? -15. Check, it works. So that other point you find just by doing what the slope says, that's the way you can check it. You can plug it in and make sure it actually works. Alright guys, 2 more now, let us out. Alright? We've done a lot. I'm tired of shit. Let's see. Find the slope. This could be the teacher, I can sit upside down, whatever. How do I find this guy's slope? What goes on the top though? Be careful. Are you guys alright? We're almost there, guys. You just help me out. We'll leave soon.
5 or -7?
Yeah, which way you want to go? I'm going to do 5 minus the other one. So 1y minus the other y. And then I got to do the same way my x's. So I got to do -3 minus the other x. So make sure the y's are on top. X is on the bottom. So I get 12 over -2. So I get -6. And then what's true about this guy? 2 minus 2 over 6 minus -4. It doesn't even matter what the bottom is.
So it's a straight line.
Yeah, if you plot 6, 2 and -4, 2,
I mean, yeah,
See it?
both the y points are straight.
so it's just going to stay at that level. Yeah, the bottom is non-zero, the top is. The bottom was 0, the top is 0. All right. Don't forget, give me back my calculators when you get your IDs back. Don't forget that.